we go.
Nice. So did you have any questions about the preparation assignment that we had?
I mean, nothing that comes to mind.
Mm-hmm.
Like, to tell you the truth, I didn't get through everything. I got through most things and then just kind of skimmed everything else and made sure I understood it.
Yeah. I think we have the same processes going on in our mind, because that's exactly what I did too.
Really?
Yeah. Because once you get to a certain point with it, I feel like it's kind of the past lessons over again.
Yeah, with the z-score and probability and yeah, everything.
And now probability, that's just the area on the applet, right?
Yeah.
Okay.
Yeah. Yep, just the area under the distribution, I think.
Perfect. Depending on if it's two-tailed or what is it? Yeah, one-tailed.
One-sided or one-tailed, yeah.
Exactly.
Yep.
Your names.
Yep, I think so. Yeah. Seriously.
Okay. Yeah. Well, quick. Okay. If you're ready for the quiz, I'm ready for it as well.
Let's do it.
Okay.
Sounds like a plan.
Sorry, we started a half hour later today.
I know, it's fine. It's always nice because I get home late sometimes, so it's nice to have time to work on things.
Yeah, if you ever want to do it later anyways, just let me know. It's no problem.
Okay. Sounds good. I think the time we've been doing it, it's been working well.
Okay.
I don't know how you feel.
Yeah, no, I have a little bit of time before and after, or before 8, so I can prepare for it and whatnot.
Okay. That's good. So any keys?
No keys yet.
I've been looking for them in the lost and found.
I appreciate it. Yeah, we're gonna check to see. Each individual building has a lost and found that they turn over to you, right?
Yeah, so they hold it for a day or two, and then it all ends up at the main one.
Yeah, we're gonna check in the snow one the other tomorrow just to make sure it's not being overlooked.
That's a good idea.
Yeah.
Just check with the custodial service.
Okay.
You go there.
Perfect.
Because they're the ones that pick everything up.
Oh, what was that?
Yeah, just they're the ones that pick everything up. So.
Oh, okay, that makes sense. Perfect. So, are you ready for number 3?
I am.
Okay. So, which hypothesis involves equality?
That's the null hypothesis, right?
Yeah.
Is that what you're going to say? Sorry.
It sure is. Nailed that one.
So the p-value is the probability of obtaining a sample statistic at least as extreme as the one that was actually observed. Use this information to answer the next question. Remember that p-value is the probability of obtaining a sample statistic at least as extreme as the one that was actually observed. In computing the p-value, which hypothesis do you assume to be true?
The null hypothesis, correct?
Yeah, yep, I think so.
It's kind of funny that information was basically just repeated.
Yeah. Yeah, I think so. Yeah, they do that a lot in this course. A lot of repetition, it seems like.
Yeah. Maybe they're trying to teach us something.
Maybe.
All right. So, oh, go ahead.
Yeah. You assume the null hypothesis to be true until you prove otherwise, right?
Correct. Yeah. At least that's how I understand it.
Okay.
All right. So suppose the null hypothesis is H naught. The mean, population mean, I think, equals 10. Use the information for the next 3 questions. Which of the following represents the alternative hypothesis for a two-tailed test?
wouldn't that? Sorry. Go ahead.
We have here. Would that be C?
That's what I was thinking too.
Okay.
Because D would be that one stands for the null
Yeah,
hypothesis.
exactly.
Which of the following represents the alternative hypothesis for a left-tailed test? And that would be B.
I think so. Let me look at my notes. Yeah, that's left-tailed. So the next one for right-tailed is going to be just the opposite of that, number or letter A.
Yep. Awesome.
And then remember that we determine the outcome of a hypothesis by comparing the p-value to the level of significance, or alpha. Use this information for the next two questions. Which relationship would result in failing to reject the null hypothesis? Okay, now we're starting to get to where this is where it started stretching me a little.
That's good.
Yeah,
Means we're learning, right?
that's right.
Okay, which relationship would result in failing to reject? So failing to reject, that's just accepting the null hypothesis, right?
Yes.
Okay. So for the p-value, or alpha, it to be equal to or wait, less than? Okay, I don't remember. I need to look at my notes.
I was just looking at my notes. I didn't write that down for some reason.
You're good.
No,
Okay.
the text as well.
You remember p-value.
Okay, so if the p is low, reject the null. It's that little saying there.
Oh, okay. Gotcha. I remember that.
Okay, so if p is less than alpha, we reject the
So
null.
B.
Yeah.
Okay.
Now I remember that. I remember that little couplet it gives.
Yeah, I remember that too.
Values low,
Yes.
reject the null.
Okay.
Oh, wait a
thank
second. This question actually would be failing to reject the null hypothesis. So
you.
that would be p is greater than a for
So
the
A.
first.
Gotcha.
The only reason I caught that is the next question is the opposite of that, so that's going to be B.
Okay. Good. I'm glad you caught that.
Thank goodness for that.
It throws me off. Yeah, it throws me off how they word it sometimes. Failing to reject.
Yeah. Yeah.
Okay. An insurance company is reviewing its current policy rates. When originally setting the rates, they believed that the average claim amount was $1,500. They're concerned that the true mean is actually higher than this. Use this information for the next two questions. So which of the following would be the appropriate alternative hypothesis?
Would that be C?
I believe so, yeah.
Let me read through that again. They're concerned that the true mean is actually higher than 1,500.
Yep, so it would be C, right?
I think so.
Because that's what they're trying to prove.
Yeah.
Okay. Trying to make
And
sense
which
of it
of
in my
the
head.
following would be the appropriate null hypothesis, H naught?
So that would be A, right? The average claim is.
I believe so.
The insurance company randomly selects 40 people or 40 claims and calculates a sample mean of $1,650. Use this information to answer the next 3 questions. Assumes the distribution of the sample mean is normal. This is a good assumption.
I would say it's a good assumption because n is greater than 30. It's a large sample.
Yeah.
Is that option here? Yeah. A.
Yep.
Nice. And then what theorem or law justifies your answer to the previous question?
Okay, so I get these 2 mixed up. I'm glad that I was happy we could use a note card on the test.
Yeah, I had to look at that for that portion.
Okay, so we're talking about distribution here, right? So, still have my note card here. So would that be the central limit theorem? Is that what?
That's what I'm thinking. Because if I'm not mistaken, the law of large numbers just means that it's more accurately representing the population.
Okay. Yeah, that sounds right.
Pretty sure it's the central limit theorem. And that's the one that we mentioned during the video instructor mentioned during his lesson.
Okay.
Which
Awesome.
the following is the test statistic? Is that the z-score?
Yeah, I don't remember that, but that would make sense because the first one's sample mean. Bottom one is the population or the sample size.
I don't remember a variable s.
Yeah, that's what I think.
Pretty sure that is what it is.
Okay. Awesome.
Oh man, I keep giving you the long things to read. I'm sorry.
It's all good. So the historical mean of sales receipts at a grocery store is $150 with standard deviation of $40. The store manager suspects that the average has decreased. She sets up a hypothesis test with these hypotheses. The null hypothesis being 150, and the alternative being less, the population being less than 150. So she will use a level of significance of alpha equals 0.05. She then takes a simple random sample of 36 sales receipts from her store and computes the sample mean, which is 144. So what is the z-score associated with this test?
Out comes the calculator.
So I just want to make sure I'm setting this up correctly. Would it be 144 minus 150 over the standard deviation of 40 divided by the square root of what is the population size? 36?
Yeah, that's what I have as well. Okay, I'll just say what I have and see if you get the same thing. I have negative 0.9.
Okay. Awesome. Just give me 1 second.
No worries.
Okay. How long did the test take you?
It took me between 45 minutes to an hour, I think.
Okay.
I remember.
Wow, you're a lot quicker than I am. It's probably my calculator that made me take so long.
Yeah,
I blamed it on that.
exactly. That'll do it. There.
I got the same answer.
Perfect.
Yeah.
And it says to round to 3 decimal places. Do we just tack on 2 zeros at the end there?
Yeah, I would assume so.
Okay. On the test, I had put 2 decimal places for several answers, and then I caught myself halfway through. I thought that could have been really bad if I didn't do that.
Oh yeah. Yeah. Well, I'm glad that you figured that out. You did really well.
So what is the p-value?
Oh, we just plugged that into the applet, right?
Yeah, I think so. And then do we shade to the right of the negative 0.9?
That is a very good question. I would assume so, because we're using the negative z-score.
Right, I mean it's it's a right-sided test.
Oh yeah.
I'm not sure if that means shade. I don't remember. My goodness.
Oh yeah.
Do you remember?
I'll pull it up right here. There's the helpful little thing here in the notes.
Okay.
Okay. So a left, if it's a left-tailed, you shade to the left, and right-tailed, you shade to the right. And if it's two-tailed, you shade both sides.
Oh, perfect. Okay. So then we do shade to the right.
Yes.
Wait a second.
Or do we shade to the left? Because the alternative is alternative hypothesis is a left-tailed, and the null hypothesis is a two-tailed.
Oh, okay. So I guess I mixed up the alternative. So the alternative is a left-tailed one?
Yeah, that's what it looks like. So
okay.
We shade to the left then?
Yes.
Is that
0.184?
Yeah. Yeah.
Okay. What inference would you make? The alpha was 0.0. Wait for that. So I would imagine that we fail to reject the null hypothesis.
Yeah, I think you're right. Cool. We're hauling through this thing.
Yeah, not too shabby.
Yeah. For what is your conclusion for this problem? So either A or C, right? So,
Yes. I want to say that it's C because we didn't prove that 150. We just proved that it's not 150. if
yeah.
that makes sense.
Yeah, I think so.
Okay. Which in a sense would prove that it's 150, I suppose, but oh well. Okay, so there are 2 types of errors that can be made when performing a hypothesis. Which one involves rejecting the null hypothesis when the null hypothesis is true?
Thinking type 1.
That's what I'm thinking as well.
Because, yeah, if it's true and you reject it, then it's type 1. Right?
Nice. Yep.
The researcher decided that instead of using a level of significance of 0.05, he will use alpha 0.01, which of the following will be true.
Oh gosh, I actually this was one I struggled with on the preparation assignment.
Yeah, so if, yeah, I think if the probability of, okay, it would increase if one is lower, the other one's higher, right?
Oh, that's true. I do remember that.
I'm trying to remember. But, man, I spent like 10 minutes trying to figure this out before I thought I had it. Oh, cool.
So I remember I kept on thinking about it the backwards way of what it usually is, but I don't remember now what that was.
So I think it's either A or B.
Yeah, I think you're right.
So we could just go with one of them
50-50
and
shot.
yeah, work on it later.
Okay.
Should we just go with A maybe, and then
Yeah, sounds good to me.
whichever one you want? Sorry, that's a lazy way of doing it, but
No, that's okay. So if alpha equals 0.05, probability of committing a type 1 error.
okay, dang it. Maybe we do have to figure that out. Can you type that that probability into the applets? Or no, not the probability, but does that act as a z-score, that 0.05?
I am not sure. I think I may have missed something during the lesson about this. But I did type it in. So I typed in 0.050 into the z-score.
Okay.
And then what should I shade with that?
That is a good question. I don't know if that would be, if that's even the right way of doing it. I'm just gonna look in the notes really quick.
Okay, I will as well.
Okay. So if alpha is allowed to be very large, committing a type 2 error will be very small.
Okay, so then if the alpha is very small, then type 2 will be very large?
Yep.
Okay, so would 20 be B then? Since we're decreasing the alpha.
Yeah, that would make sense.
Okay. And now I have no clue where to start. Do you have any idea of how to start question 21, finding out the probability?
No, I don't even remember reading that in the homework. To
Me
be
either, actually. And I've been looking through the text. I'm sure it's in here somewhere, otherwise it wouldn't be on the quiz, but I just can't find it.
Can't find it either. Like, not yet, anyway.
Yeah.
Okay. So. What do you think we should do on that one?
I don't know.
I guess. Yeah. I don't
What was
really know
that?
yeah, I really don't know where to start either.
Yeah, I'm just gonna Google and see.
See if you can find anything.
Yeah, figure out at least the process to do it.
Okay.
Not having much luck over here.
I'm still looking in the homework because I mean, there's got to be something in there.
Yeah, you think so. have no idea.
Yeah, and, I thought that. Was there a question like that on the assignment?
Let me pull it back up really quickly.
Because if there was, we could look on the answer key and see the answer and see maybe how.
Okay, let me see here.
So on part 2,
Mm-hmm.
on question 9, part C, there's one that's similar.
Oh yeah. Okay. Wait, is that it? Just a 1 in 100 or 1% chance?
I guess.
We're supposed to put 2 decimal places. Maybe just 5.00?
Maybe we could try it at least. I guess.
Maybe we were way overthinking that, but that seems pretty simple.
I'll type it in. I'll submit my answers.
Okay.
Really quick.
Sounds good.
See how we did here. Yeah, it looks like we just missed the last one.
Darn, so it's
and
not 0, 0?
No, it gave me the right answer actually.
Really?
So yeah, it says it says answer :5.
So it didn't take 5.00, but it'll take 5?
I guess. Unless
that's kind of silly since it says round the 2 decimal places.
Unless never mind. That must have been my answer.
Oh, okay.
Never mind. Oh,
Gotcha.
sorry about that.
No, you're fine. No, I was really confused. I thought, wow. I thought even Eilern didn't do that.
Yeah. Okay, actually, I lied. We missed. I just scrolled down to the bottom, but we did miss question 6 and 7, and then the last one.
Okay. 6. Really? Oh. I think that was my bad.
You're good. Probably. So those would probably be flip-flops.
Yeah,
I don't know.
It would be. I was confused as to which one was which.
I don't know. I was too. Good. Yeah. So.
Okay.
Just the last one, then we need to work on, but. I'm gonna jump back in there.
Okay. Just let me know when you're ready for the answers.
All right. I'm good. I'm on 3, so.
Null hypothesis.
4.
Same, null.
No. Okay. 5
C,
is C. 6.
A,
7. B.
B, yeah,
8.
A,
9.
B,
10.
C,
11.
A,
Whoever designed this course did a really good job.
agreed.
12.
A,
13. B.
C, yeah, excuse me, B, yeah. I was thinking C, central limit.
Yeah, good. That's the Z score, right?
Yep,
Okay, 15.
minus 0.900.
16.
0.184.
Okay, 17.
Failed to reject.
18.
C,
19.
type 1,
20.
B.
Okay, and then 21 here.
Yeah, I still have no idea what to do for that one.
Me neither. I mean, it all depends on how much time you want to spend. But
Yeah.
do it as is, or we could keep plugging away at it.
I think I myself am just gonna go ahead and plug in a 5
Okay.
and give it a shot. Got a few other things to do for homework tonight.
Okay.
But you can do whatever you want to with that. So I'm gonna go and submit. All right. We missed just that last one for a 95.65%.
Hey, I'm actually happy with that too, so I might just
Yeah,
I might just submit that too.
there you go.
Yeah. Well, thanks, Thomas.
Yeah, thank you very much.
All right, well, we'll talk to you later. I'll just go ahead and submit the link. It's not a big deal at all.
All right, sounds good. Well, thanks again, and I will see you next week.
All right, talk to you later.
Have a good weekend. Bye-bye.
You too, bye.